I am Salman, and my partner is Balo. The work was divided as follows. The setup function of the code, the testing, and the compilation of the report was done by Paolo. I did the rest of the code, as well as the demo and the diagrams. In order to get the working that we required, we set up an ADC, a temperature resistor, a thermistor, and the Raspberry Pi with a button. The button was connected to a normal GPIO open and was set to pull up as a pull-up resistor. The 3.3 volts was set out so that the switch, the ADC, and the thermistor was connected to it. The ADC was set so that VDD and V reference is at 3.3 volts, where V out of the thermistor was connected to channel 1. The clock was connected to the clock output of the Raspberry Pi. MISO and MOSI were connected to the Raspberry Pi's MISO and MOSI respectively, and the chip select was connected to CE0. The ground was all grounded commonly and connected to the ground of the Raspberry Pi. The code runs as follows. The user first decides to run it. Then a setup of the default is run. Then a setup function is run, setting up the pins and the headings. Two threads then occur, one performing a task when the button is pressed to switch between the different frequencies, the sampling periods. Another is there to print the readings, and as well as calculating the runtime and the temperature from the ADC. These two threads work together to perform a specific goal, like a superorganism. The temperature reading function thread calculates and prints the runtimes of the readings and then goes through a delay of the sampling frequency. Then it runs the thread again, and this happens indefinitely until Ctrl+C is pressed. The run toggle button function is a thread that runs and checks to see if the button is pressed. If the button is pressed, it changes the sampling frequency, and a delay of 250 milliseconds is put in place before running again. If the button is not pressed, it will just do the delay and run again. This delay is in place so that no double clicking can happen. It works similar to a debounce. Looking at our code, we can see that it first imports all the libraries that we'll be using. It then goes into the main function and sets up the default variables being used. The sample time is then set as well. The starting time is then set as well, and the setup function is being called. The setup function sets up each pin that's going to be used, where it'll be the SPI interface between the ADC and the analog input channel on the ADC. This is the chip select, and it also creates a button for the button that will be used to toggle the time. After it creates the setup channel, we can see that it starts a thread for toggling time and for printing the output. In the toggling time, it first checks to see if the button is pressed and then changes the frequency required. This frequency is selected from a list, and the select time is used to find which item in the list it must choose. It's incremented by 1 each time, but if we mod it by 3, we'll either get 0, 1, or 2, and this will allow us to choose which item in the list we need. The sample frequency is the actual frequency at which we will be taking samples. You can see it calls a time thread after 0.25 seconds. After the threaded of the toggle time is ran, it will go to the return and start the printing thread. The threaded time will still be running, as this line here allows it to be run over and over, and start was used, so it will still go to the next line afterwards before completing. For the printing. In the printing, we can see that it calculates and prints the output of the temperature sensor. It uses the global variable sample frequency as the toggle time did as well. The runtime is calculated by using the current time and minusing the start time that's given as an argument when calling the function. This while through allows the frequency to be changed instantly. It would be different than using a time thread, as a time thread would execute the line and then would only change the frequency after it's been pressed. For example, a 10-second frequency was used and the next would be 5. So at 10 seconds, it selects the ADC and prints the output. Then it will start counting again. By using a time thread, it will wait for the 10 seconds as it will start the thread already and wait for the 10 seconds before it actually starts. But within those 10 seconds, if the frequency is changed, it will still wait. This while loop allows the sample frequency to be changed instantly or simultaneously as it's waiting. This allows the program to react faster to the button pressed. This daemon, um, this daemon function set to true allows the threads to completely stop once the whole program is stopped. After this runs, it will still go to a while true, and this will just allow the code to continue running and on and on and on until a keyboard interrupt Control C is pressed. I will now show you a demonstration of my code. First we run it, and then it displays the burst reading at 0 seconds. We can see that it's around 30.57 degrees. This makes sense as I was rubbing it beforehand because this is not my first attempt. The next printing happens at 10 seconds, as we can see, and the temperature is more or less the same. The next is at 20 seconds, where it decreases slightly as time has passed. Then the next will be at 30 seconds. Then, if we press the button, it's now going to start printing every 5 seconds, so the next would be at 35. If we use time threading, the next would have been at 40, and then it would start incrementing at 5. This is because of our while loop. Pressing the button again will make the sample happen every second. Now, to show that the temperature sensor works, we can rub the temperature sensor and thus increasing the heat. As you can see, there's a slight increase in the temperature. When letting the temperature sensor go, you can see it's starting to settle and then eventually fall down slowly. In order to exit, we can press Ctrl C. But before that, let me just show you that when pressing the button again, it will switch to taking samples at 10 seconds. So the next would be at 100 seconds. You just need to wait 100 seconds, and then it'll be 110. Now, in order to exit, we press Ctrl C. This triggers the keyboard interrupt. The threads will also all close, and then leaving nothing being printed out on the screen. So all we can see is the reflections on the screen. As we can see within our readings, everything is all good. This is fine. This is because the readings are fairly accurate to what we expect. The button functionality also works somewhat decently, although I would find a way to improve it, as you would need to press the button quite firmly for it to register. And there's no way the user knows whether the sampling period has changed until the next the next sample happens. I would have included a feedback to the user if more time had allowed. Other features I would included would be a light sensor as well, if more time allowed it. There's also an issue with my circuit where the button is really close to the pins of the Raspberry Pi. I would change this in the future, as I know it can be somewhat inconvenient. I would also implement a different way of closing the program, as pressing Ctrl C is not always available. For instance, in the fish tank, somebody would not always have access to a keyboard in order to exit. Thank you.